This video is how to connect a branch run to a main, sloped pipes with a vertical lateral. I did this video once before and it was incorrect. Here was the incorrect version of it. Isolate this. They have a sloped line with a lateral placed in it. And we drag a line off of here, slope it, I did that and then just work backwards from there to place this fitting in the main. However, this is sloped at 1%, about six tenths of a degree. This, on the other hand, is vertical. With a socket fitting, this is not physically possible. If we look at the angle here, we'll see that it's greater than 90 degrees. When these pipes go into that socket, they're at right angle, 90 degrees. Doesn't make any difference if it's a PVC, copper, or carbon steel socket. It's 90 degrees. So this is incorrect. Let's look at how to do it correctly now. We'll isolate the pipes we're going to work with. This line has to be sloped parallel to the main. I'm going to place a 45-degree fitting on this. We want to drag it down beyond the center line of the main. We're going to need this apparent intersection. Before we get started, let's tighten this up a bit. Now, since we're going to be working on this line, we want our coordinate system to be parallel to that center line. So we'll use the 3-point alignment tool here. X-axis is down here. Y-axis is up here. Now, if you're going to be doing this a lot in the same model, you can go over here and save the UCS, and I'd call it, since we were looking at the Y-axis on that line when we were in the world coordinate system, not this one, but the world, it was Y slope. I guess I already have it. So let's go back to the world. And it puts me back in it. All right. And we need to look at it from this side. You can see, looking at this pipe now, that we're looking straight down it. There's no slope. We need a line from the apparent intersection. back to the top. Draw a line from that intersection. I suggest putting ortho on so you make sure that line's straight and level. Move the pipe and the fitting there to there. And we'll make this connection. Find it easier working from this side. We'll check our continuity. Now you notice I have it set for 5/10,000ths of a millimeter. In a previous video, I showed you where Cadworx and Caesar 2 recommend 1/1000th of a millimeter. Well, I'm going to err on the high side of that, or low side of that tolerance with 5/10,000ths. Hoping that will meet the requirements of stress analysis programs. However, I do recommend that you check with the people running the stress analysis and find out exactly what they do require for connection tolerances, because it's much easier to do it right the first time than to have to go back and move a bunch of fittings which may affect connections down the line on a particular run, and it could turn into a real nightmare cleaning it up. So set up your tolerances according to what the stress analysis program needs and do it right the first time. You can see we're going the wrong way with that. We'll use the flip direction function. Put it in straight up. The reason I pull this up, when you insert this lateral, sometimes it'll pick up on that end point and the lateral comes in all cockeyed. Now we can erase our construction lines. And we can tie this into our lateral. We'll check our continuity and we're good. Back to the world. Now let's check some elevations here. The whole object of this exercise is to keep these bottom of pipe elevations the same. Bottom of pipe, bottom of pipe, 152,589, 152,589. See what these look like. 151,562. 151,562. So everything remained the same, and that's what we wanted to see. Now, I did look at, there's another way of doing this, and that would be rotating this lateral in that direction 5.729 degrees, which would match the slope of this, and then you could do, if you could do this arrangement just by rotating this angle, this lateral at a 5.729 degree angle, and then come off with a 90 degree, and that'll put the 6% or 1% slope on this line. However, the problem with that arises with, it only allows you to bring a branch line off going in this direction. You can't go in that direction. This arrangement allows, first of all, a little room for wiggle room for constructability for the contractor. Plus, if you want to bring a line off going north, this is south, rotate the fitting 180 degrees and then adjust the angle for the slope. And I put in a flange connection there. I didn't on this one, but this is, if this run is no longer needed, they can disconnect it, move the pipe instead of abandoning it in place, put a blind flange on that and cap it. You'd do the same if you were going to put in future connections with this fitting. You put your laterals in, put a flange and blind flange on it, and you're ready to go for future. Well, I hope that helped clear that up. This is the correct way to connect a sloped branch to a sloped main with a 45-degree lateral in the vertical rise.